So on your additional notes, there is a ton of questions where the main strategy will be, surprise, surprise, in trigonometry, draw a triangle. And can you use angles in standard position, reference angles, and the cast rule to help you with that? And your big idea. So first of all, if cos of theta is 3 over 8, you know on your unit circle that your x-coordinate would be 3 over 8. You know it's not in quadrant 1, so with your cast rule, if it's not in quadrant 1, what quadrant does it have to be in? It has to be in 4. Then we go and in quadrant 4, draw a terminal arm and go back to your nearest x-axis so that you can label a reference angle. And you've made a right angle triangle. And what do you know? You know that cos of theta is 3 over 8, so that means cos of your reference angle is also 3 over 8, and you can label the adjacent side as 3 and the hypotenuse as 8. So drawing this diagram uses like 4 big ideas that we've developed already. What is an angle in standard position? What's a reference angle? What's your cast rule? And what does cos mean? Adjacent over hypotenuse. Once you've done that, would it be hard to find this other side? No. A squared plus b squared equals c squared. In fact, I want you to do this in your head, because you're going to get really good at these. Are you going to take and add them or subtract in this situation? Subtract. 64 minus 9 square root of 55. And then from here, I know that sine of my reference angle is root 55 over 8, so sine of my actual angle will be negative root 55 over 8. Why is it negative? Because it's in quadrant 4, and your cast rule says sine is negative in quadrant 4. Same thing. Tangent of my reference angle would be root 55 over 3, so tangent of my actual angle will be negative root 55 over 3, because tangent is negative in quadrant 4. So all of these ideas come together in a lot of these questions. And if you can draw the triangle in the right quadrant, then you're going to be able to solve them quite easily. Now your gut reaction to this question is probably no, because you just did your unit circle quiz, and this wasn't one of the points that you labeled. However, there's a lot more points on the circle that weren't labeled, right? I didn't do 20-degree family, 12-degree family, 7.34218-degree family. There's an infinite amount of points on the unit circle that we haven't labeled. And now the question is this one of them? So in your problem solving, if you get a question like this, and this is one that has come up on the provincial exam, and you're like, ooh, I don't know how to do this. It's a trigonometry question. What do I know? And I would say, go back to your 3 big ideas. Is it helpful to know that this is cos theta, this is sine theta? Is it helpful to know tan theta is sine theta over cos theta? Is it helpful to know that sine squared theta plus cos squared theta equals 1? So then you problem solve and try each of those big ideas. In this case, I would either use, this is always true, and you know this is your cos of theta, and this is your sine of theta, so that's using 2 big ideas. You could also just use, if it's on the unit circle, this is the equation of the unit circle, that x squared plus y squared equals 1. If these things are true, then this point is on the unit circle. If they're not true, then it's not. So basically we're asking, and these are the same thing, is sine squared plus cos squared equal to 1? Well, let's check it. If I do the sine, root 6 over 3, and I square it, and I do the cos, which is root 3 over 3. and I square it. What do I get? Well, this would become 6 over 9 plus 3 over 9. And since it's equal to 1, you would say, yes, it's on the unit circle. If it equaled any other number, you would say, no, it's not equal. Okay? Something to be careful on, because this came up on an exam. I'll just do it as an extra question. They gave a point, and a lot of students lost a half a mark on this question. They gave a point, let's say, I'm really, like we had root 6 over 9, and no, we had, I'll make it really close, but not work out. And students did this. Maybe I'll just use the x squared plus y squared equals 1 because I'm being lazy and don't want to write out the extra 3 letters for sine and cos. Okay? And then they did this. And on first glance, you're like, I like what they did. They're checking. They found out that it didn't equal and said, no, it isn't. But on the exam, they would lose, because this is not true. They lose a half point at this point, because you're trying to show that it works. So notice in my question, I asked the question, and then I didn't make it equal to 1, because I don't know if it's equal to 1. I asked the question, and then I checked, found out it's equal to 1, and could say yes. In the student work here that lost a half a mark, you're assuming it's equal to 1 before you've checked. And in the end, it wasn't. And so this is actually not true, as well as this. Those are non-true statements that you are saying are true in your work. So they're fussy about that. You want to check if something's true. Don't make it equal, or sometimes we did this in grade 11 and grade 12. You sort of set it up with a line with your right side and your left side, and then you check both sides. The left side was 1, the right side, root 6 over 3 squared plus 2 over 3 squared, and you got 10 over 9, so then you could go no. You split it up, and you're checking, you're verifying if those things are equal. So again, this one starts very similar to the one that you just did. And it is checking to see if you can find y. Again, it's a trigonometry question. The number one thing you'll want to do is draw a triangle, if possible. So again, using angles in standard position, your cast rule, reference angles. We know that it's in quadrant 3, so I can draw an angle in quadrant 3, go back to my nearest x-axis to make a right-angled triangle with my reference angle. And I know that cos of theta, from my big idea, my x-coordinate is cos of theta. So I know that cos of theta is negative 12 over 13. That allows me to label something for my reference angle. If cos of theta is negative 12 over 13, then cos of your reference angle is 12 over 13. Reference angles always deal with positive values. So if I go to my triangle, I can label the adjacent side as 12, the hypotenuse as 13. If you recognize the 3, 4, 5 triangle, do you recognize this one? This is another famous one where all the numbers are nice. If not, you have to do mental math. What is 169 minus 144? 25. So what side? How long is this side? 5. It's another beautiful Pythagorean triplet where all the numbers are the same. We're going to find a bunch of them this year. And some of you on a test, you wouldn't even have to do a squared plus b squared equals c squared because you might recognize the famous 3, 4, 5 triangle. This is the famous 5, 12, 13 triangle. And then y, if I want to find sine of theta, it's going to be opposite over hypotenuse, and using my cast rule, since it's in quadrant 3, sine would have to be negative. If I circled that as my final answer, again, I would lose a half a mark. Reread the question at the end. If this is a point on the unit circle, right, and you know that that's supposed to be sine of theta, what does the question ask us to find? The question said find y. So the very last thing I need to do, I know that those are equal. I may know that you know that they're equal, but the question said find y, so when we circle our final answer, it should be y equals, not sine theta equals, even though you know that they're the same, right? But the marker on the final exam, the marker, me on your test, I am not allowed to assume you know something, right? Otherwise you could just be like, Mr. JR, I know all this, and you just hand me back the test as soon as I give it to you. And then I go, oh, I assume you know this, so I just give you 100%, right? You do that? Yeah. I mean, it would be a good deal, right? You wouldn't have to do as much work. I wouldn't have to do as much work. We'd probably only get in trouble once you get to university, right? Because then all of a sudden, someone would be like, why did we give them this scholarship? Well, they said they knew 100%, and I assume they knew 100% all year. They're not getting anything right in university. Oh, something went wrong. So we read over the question again. If it says find y, we make sure that we're very careful with that. We saw that in our last unit, right? I had some questions that said find f inverse of x, and you guys just left it y equals. You take that extra step and write f inverse of x.
Would all grade 10 students with the last names starting A through M please go to the front foyer to get your pictures? That's all grade 10 students with last names starting A through M. Please go to the front foyer for your pictures.
So if we know the quadrant, it becomes really important for cast rule stuff. If we know a quadrant and a reference angle, it's super powerful. So what we're going to do in the next little bit of notes is just think about how could we, either with our calculator or without our calculator, find out where an angle is. So I've got a huge angle here, 4,300 degrees, right? That's very hard to visualize where that ends, because it's going around the circle so many times. So if you had a calculator, and you went, oh, I could divide by 360, because that would change this to 11.94, and every 360 is a full revolution. So it does 11 full revolutions, and then 0.94. If we drew this out, ooh, I'm going to hypnotize you again. 1, oh my goodness, I can't even count. That's a lot of times. We're going to just, can you imagine that's 11? I don't know if it is. Okay, it's not quite, but that's okay. Imagine it's 11. And then 0.94, can you see goes over half, over 3/4, halfway around. This is a quarter of the way around, 3/4 of the way around. Does it make sense that it ends in quadrant 4? Now, if I didn't have a calculator, I've got it minusing 11 here, but I would probably, like, every time I minus 360, do you agree you get something that's coterminal? Because every time you take away 360, it would end in the same spot. Mathematically, mental math-wise, I think to start off I would take away 10 360s. Because mathematically that would be easy for me to figure out. 4,300 minus 3,600 gives me 700 degrees. Still over once around. I would then say, okay, I'm going to take 360 and minus that again. And I get 340 degrees. If it was without a calculator, that's what I would do. Can you see that 340 degrees is in quadrant 4? So we would say that right? But the word we learned when angles end in the same place is coterminal. So we could say that 4,300 degrees is coterminal with 340 degrees, and 340 degrees, I can see that mental math-wise that that ends in quadrant 4. So this dividing is really nice if you have a calculator, but what is it? Like more than 75% of your provincial exam is non-calculator. You get 3 hours plus an additional half an hour for your provincial exam. So they will give you 3.5 hours. You'll start at first thing, 8:30 in the morning, and you will get right until lunch to do it. Probably with instructions, you'll get to like 12:05 to do it. In that, you only get 45 minutes with your calculator. 45 minutes with your calculator, and then the other 2 hours and 45 minutes is non-calc. Yeah, start training. Do a couple push-ups every morning so that you have the stamina to do that exam. Okay. Radians. So we could do the same thing in radians. What's really nice about radians is if the fraction is already in lowest terms, which this one is, it is really easy to tell the reference angle. This is going to be coterminal with something in the pi over 6 family. Pi over 6 will be our reference angle. We just need to find out what quadrant it's in. Now again, if you had a calculator, you could divide this by 2 pi. So I'm going to just double check what that is. And this is a little bit, this is good practice. See if you can type that into your calculator. Negative 1.916 repeated. If it was positive 1.9, can you see that it would be in quadrant 4? Now it's negative 1.9. So if you think about negative 1 would go all the way around the circle once, and then 0.9 is over 3/4 is going to end in quadrant 1. But we are going to develop a shortcut for these using mixed numbers. So if I take negative 23 over 6 and I change it to a mixed number, I get negative 3 and 5/6. Now, that means negative 23 pi over 6 is equal to negative 3 and 5/6 pi. And we're going, in the shortcut, we're going to think about our circle in terms of pi. So would you agree that this is 0, and all the way around was 2 pi, halfway around is pi? And if you keep going, pi, 2 pi, does it make sense? This will be 3 pi, then this will be 4 pi, coterminal. And then this will be 5 pi, and this will be 6 pi. And you start to notice a pattern that this is always odd pi, and this is always even pi. And of course, this is pi over 2. So if I have negative 3 and 5/6 pi, the fact that it's an odd number, the negative 3 would go 1, 2, 3. The odd number tells us that we're going to be at negative 3 there. Then the fraction 5/6 is over half. So I need to go over half. Oh, I'd be in quadrant 1. If it was less than half, you would have been in quadrant 2. So we use the number as a mixed fraction to figure out, am I on my positive x-axis or my negative x-axis? And then the fraction part saying, should I go over half or not, moving forward? So that tells us it's in quadrant 1 as well. Okay, so I've got a handout for you to practice this. I send any extra down any rows? Okay, then I've got to make 3 more copies. I'll do that quickly in a second. So I'm going to get your 3 copies in a second. I'm going to give you a couple of examples from here to do together. And then, while I make the 3 copies, I want everybody to try. In this row, you can steal questions off of this row while you're waiting. Okay? So there's 2 things that it says to do. Assignment 1, assignment 2. This is not to hand in. This is just for your practice. Okay? And what we're going to look at here is, in assignment 1, it says, ignore the sine and cos, and you just want to find something that is coterminal with the angle in the first, it says, first positive revolution of the unit circle. That means on the first time around, what's coterminal with the angle that's given? And if we do number 1, we're going to do a couple of them together. So number 1 is 13 pi over 6. 13 pi over 6 is going to end somewhere. Okay? I already know that it's going to be part of my pi over 6 family. If we can find out what quadrant it ends in, then it's going to be coterminal with whatever pi over 6 family is in that quadrant. So, how can we go about doing this? If I change this to a mixed fraction, 13 over 6 is 2 1/6. 2, right, is an even number. I'm going around, that means I would get to here, and then another 1/6 more. It's in quadrant 1. So once I know it's in quadrant 1, what's my pi over 6 family in quadrant 1? It's just pi over 6. So 13 pi over 6 is coterminal with pi over 6. Let's do number 3 together. 19 pi over 4. 19 pi over 4 as a mixed fraction is 3 3/4
Sorry for
pi.
the interruption. Again, any student grade 10 with the last name A through M, please go to the front foyer to pick up your pictures. That's grade 10 students, last name A through M. Please go to the front foyer for your pictures.
Now that I see it's 3 3/4, can you see that that's quadrant 4? Because 3 would be on the odd negative x-axis, and then 3/4 is over half. It would get into quadrant 4. What is your pi over 4? In quadrant 4? Coterminal with 7 pi over 4. Okay? You could also find coterminal angles. Remember, we find coterminal angles by adding or subtracting 360 or adding or subtracting 2 pi. So another strategy that students use in this question is if I start with 13 pi over 6 and I subtract 2 pi, again, you're going to get really good at changing your denominator. Do you see that 13 pi over 6 minus 12 pi over 6 gets you pi over 6? And 19 pi over 4 minus 8 pi over 4, that would give me 11 pi over 4. I'm sorry, that is 4. And then I'd have to subtract 8 pi over 4 again. What did I do wrong? Did I make a mistake here? Yes, I did, didn't I? I'm checking my answer with the second method, and I found out I made a mistake in the first one. My mixed radical is wrong. What should it be? It should be 4. 4 3/4, which means it should be in quadrant 2, which means it would be coterminal. What's your quadrant 2 pi over 4 family member? 3 pi over 4. And oh, this is where I was like, uh-oh, something went wrong with my math because I'm doing a second method to check, and my second method's not matching up. Now, the subtracting is really nice, but could be annoying if the number was really, really big. So in number 5, there it is, 101 pi over 4. Oh my goodness, we'd be subtracting 8 pi over 4 so many times till we get to the first revolution around. So this is where the mixed fraction. How many 4s go into 100?
25.
25 would make 100 of them. I need to have 1 left. And you see that 25 1/4 would end in quadrant 3. This would make this coterminal with, what is your pi over 4 in quadrant 3? 1 more. You see how that strategy of knowing 1 more and 1 less can be really helpful in remembering your unit circle? So quadrant 3, your numerator will be 1 more than your denominator, it'll be 5 pi over 4. Okay, that is assignment 1. I'll do these 3 questions with assignment 2. Assignment 2 says for question 1 to 8, state the coordinates on the unit circle for that angle. And in quadrants 9 to 32, it actually wants you to evaluate what is cos or sine. So in question 1, we figured it out, it's coterminal with pi over 6. Look at your unit circle. The coordinates of pi over 6 are root 3 over 2 comma 1/2. That means the coordinates at 13 pi over 6 would be root 3 over 2 and 1/2. Pi over 4 family. It's coterminal with 3 pi over 4. Pi over 4 family is always root 2 over 2, root 2 over 2, but because it's in quadrant 2, your x coordinate would be negative, your y coordinate would be positive. So you have negative root 2 over 2, comma root 2 over 2. And finally, in quadrant 4, pi over 4 family, so I know my coordinates are root 2 over 2, root 2 over 2, and they'll both be negative because it's in quadrant 3.